Hi, my name is Sean Johnson. I'm giving a talk today about writing reliable tools in Python. It's one of my first talks in a public place, and so I'm incredibly nervous, as you can possibly imagine. A little about me. I'm a continuous delivery engineer at Gumtree, little website you guys might have heard of it. Formerly, I was at an insurance company called IAG, and before that at the NBN. Sorry. As I said, I'm extremely nervous new SyPy house. I'm also an admin of a group called PySpackers. This is a lot of records. Then use a small one, the big one. Cool. Hello? There we go. Okay. I'm also the Australian admin of a group called PySlackers. We're an online community in the Slack application. We do everything Python. People who are new to Python, people who have been in Python forever. We've got channels for Django, Flask. If you have any questions, feel free to join us, pyslackers.com. So, why do I write reliable tools in Python? A lot of it came from my time at the NBN when I was on call. That's particularly important when you're on call to have reliable tools because you're going to get calls at 3 a.m. when stuff breaks. I was tired of getting calls at 3 a.m. when stuff broke. I had a new baby. My wife did not like it when I got calls at 3 a.m. So I decided, how can I get better? Luckily, another event happened somewhat recently that kind of helped the whole reliable tools being the sort of thing that you need. Does anyone know what happened on February 28th this year? No. This, someone at AWS mistyped a command and brought down S3 for the US East 1 or 2. Broke a lot of the internet. A lot of what I try to avoid is stuff like that as part of writing reliable tools in Python. I don't want to be that guy who comes in the next day and says, sorry guys, I was cut off by one error, or I didn't cover something in command, or I didn't have proper unit or integration testing for my command. So what makes a tool reliable? A few different things. Methodology, like your basic development ideals. Your quality of a tool, be it your quality enforcement and your encouragement of developers to write quality software. Your tool set, so picking the right tools and requirements for getting that reliable software up and running. And feedback, especially important. Getting immediate and fast feedback for what you're doing, and especially what you're doing wrong. I feel like as developers, we make a lot of assumptions on what software needs to be. And a lot of that fits what we need to be, but it doesn't always fit what other people want to be. So methodology comes in a few different flavors. It needs to have simplicity, documentation, and adequate testing. As part of simplicity, when you're developing a tool, pick a single actual problem to solve. I find myself doing this a lot because I like playing with new libraries, as I find a problem that doesn't exist yet. And solving that doesn't help anyone but me. Pick a target audience. If you're part of a DevOps team and you're helping something like developers deploy new software to say Marathon or Mesos, make them your target and make sure that they're included in part of your initial planning and strategization. Documentation. Write the documentation that you want to see at 9 a.m. when you're starting a new project. Write the documentation that someone wants to see at 3 a.m. when it's broken and they don't want to call you. Be explicit, have examples, and test your documentation. This can be as simple as giving it to other people, making sure that they go through it and validate the things that you're writing. It can also be stuff like automated document tests. There's a lot of nice stuff in Python that I'll cover in a little bit that helps those kind of things, that lets you physically test your documentation. And the fun testing period. If you've ever been involved in some long-term software development, you tend to see this be kicked around a lot. You generally want just a little bit of manual testing, a little bit more integration testing, and as much unit testing as you can. Unit testing is free, it's cheap, and it's fast. In order to kind of achieve that, you want to keep your functions specific and testable. You generally want things to have single inputs or simple inputs and simple outputs. You want to keep your command line integration to the required minimum, so not a lot of insane integration framework testing. And what I found helps me a lot is there's a book called Obey the Testing Goat. which is a system for describing test-driven development. It's helped me immensely as a software engineer learn how to write tests and how to write reliable software. So the second aspect, which has a little bit more impact on actual tools, is quality. A lot of what we do as part of DevOps and my job as continuous delivery engineer is we try to push that quality left. So we want that fast feedback. We want things to fail right away, and we want developers to know that something is broken before they commit, as soon as they commit, and as soon as the integration tests run. There's a few things that you get in the Python ecosystem that make this really, really nice. Stuff like the implementations of PEP 8 around Flake 8 or Pilot, something like auto formatters like isort, coverage tests like PyCoverage and PyTestCov, stuff that helps your poor friends who are stuck in the enterprise, who are testing on Python 2.6, Python 2.7, migrate to the new world with Tox, which lets you test against multiple Python versions. And then semantic versioning and some tools around that as well. The first I'll cover is Flake 8. Flake 8 lets you catch bugs before they become bugs. It's something you absolutely want integrated into your editor and running every single time you save. VS Code, the new Visual Studio Code, is absolutely fantastic for this. Helps you catch those little typos. If you're like me and you're a little bit dyslexic, it's a huge, huge saver. It's crucial in languages like Python where you don't get type safety. If you're doing something weird or you're calling a method that doesn't exist on an object, that'll help you catch it. It makes collaboration easier. You have a standard sort of set that all your developers have to play with, especially if you're doing any kind of open source development or development in a team. Having those enforced checks and auto documentation helps a lot. And my final thing, just set the line width to 120. No one likes 80 characters, I'm sorry. isort and auto PEP 8, those are in the auto formatter category. These are tools that will kind of grab your software and make automatic changes. You generally want to keep these pretty minimal. isort is nice because it improves the legibility of your imports. All it really does is sort your imports alphabetically, helps you catch things like duplicate imports or importing from stuff that you're not using anymore. Auto PEP 8 is an auto formatter that will reformat your code. Popular with some, I find tends to break a little bit for me, so your mileage may vary. Yeah, there's a huge amount of tools in there. One of them is YAPF, which is yet another Python formatter. Sure. That's my favorite. It's Chewy's favorite. It's also really nice, and one of the things I saw recommended in a few guides there. It's also got this cool ASCII logo that happens every time you do the Tox tests, which annoys my coworkers so much, and I love it. High coverage. So coverage is a big aspect of automated testing. It's kind of also a thing you can go crazy for. You generally, unless you're really careful, don't want to target 100% coverage. It's nice to have if it comes naturally. If you try to force it, you'll get bad testing practices like doing things just so they pass coverage. If you're anything like me, your achievements in games drive you. So getting to that 100% is really what you want. So pick a reasonable sub 100% target for our new project. I like to do 90% on new targets. Make it so your automation for building testing software fails if it falls below 90. For existing projects that you're trying to uplift, I generally say as long as it was higher than it was the day before, that's fine. One of the little things that trips people up is you want to make sure that you're combining your Python 2 and Python 3 reporting. If you have a tool like Tox that runs multiple implementations of Python, you want to make sure that your code paths for coverage are being added up in both. Tox. Tox is a tool that runs multiple Python implementations. So it will run your Python 2.7, 2.6, 3, 1, 2, 3, 4, 5, 6, etc., etc. Helps you have a full test coverage suite for systems where you need it. Myself, in the enterprise, I only generally target 2.7 and whatever our data center standard is, usually 3.4 or 3.6. I like to configure it so it'll just run against whatever's available and skip anything that's not available. I've got a little example here that says, we've run all the basic Tox commands, we've skipped Python 3.4, 3.5, but we make sure that we're enforcing against Python 2.7 and 3.6. This is especially important as we do tend to now, 2020 is only 3 years away when Python 2.7 is going to officially hit end-of-life support. which means we actually have to stop using it, which means we actually have to test against new stuff. So if your tool implements these tox tests, you're going to catch it right away. It's particularly popular in new automation to test against like beta versions and have it okay if it's failed. And then just in like a notification, like email saying, hey, Python 3.7 has failed. It's beta, it's fine, but just here you know about it. So am I going too fast? Okay, alrighty. Semantic versioning. Semantic versioning is incredibly important if anyone is consuming your application. If it's just you, you can bump versions, you can set it whatever you want. If someone else is consuming your application, ensure that you know how semantic versioning works. It generally comes in three groups. There's the patch version, which is the smallest thing, which means I fixed something or added a slight new functionality or I tweaked something. There's the minor version, which means I've made either a minorly breaking change that won't take much to fix, or I've just added some new improvements that are backwards compatible. And then there's the major version. The major version of that. I've rewritten it to be entirely in Cowseg and all that kind of fun stuff. When you're dealing with the public in terms of GitHub repos, semantic versioning is where people are going to yell at you if you break it. People don't want their software versions to break if you're breaking or not breaking semantic versioning. When in doubt, version bump and use depreciation warnings whenever possible. Next is the common tool set that I tend to use when it comes to Python utilities. A few bits in here. Click is a command line implementation similar to GetOps in the Python native library. PyQualify is a schema validation system. Continuous integration is our normal continuous integration as part of build and software automation. And Sphinx and RST is our documentation and automatic testing. Click is so simple and so nice. It's part of the same group of projects that do Flask. I don't know if it's by the same author or not. Chewy will probably shout at you later if it is. Awesome, cool. So Click is like Flask for command line APIs. It lets you easily declare command lines with decorators. It lets you group actions of command line items in case you're building a large modular application. And it's simple, it's clean, it's almost self-documenting. It's even got very common bits in here that will have prompts for if you want to make an interactive application or automatic generation of help documentation. PyQualify was originally a Ruby project before it was stolen ported over to Python. I find it super handy if I'm distributing something to software developers who don't normally use command line tools. Being able to define a schema for JSON or YAML means that any questions about what's wrong with their application when it's running will be upfront and present before they get to you. It lets people kind of own their own troubleshooting. It allows things like external standards to be enforced in tools. Part of what I'm doing at the moment is some automation of services in Mesos and Marathon. Mesos and Marathon has concepts like the maximum amount of CPUs and memory that you can schedule for it. As part of what we're doing, we want to set a standard for what developers can request. So we've given something like limitations of the amount of memory that they can request as part of the schema YAML. And that'll fail validation right away before it starts spinning things up and get confused. It can be difficult to manage, but it's worth the pain. It's something you're typically going to have to change every single time you add new features to your application. It's going to be the first thing to fail in your unit integration tests when something goes wrong. It can also be a little bit painful to manage all the external YAML configs that you use as part of your testing samples. Myself, as for a basic application, I'm up to about 20 different YAMLs as all the kind of like different scenarios that I want to test. Invalid inputs, inputs over limitations, stuff like replacing the environment variables inside YAMLs, that kind of thing. Continuous integration, the lifeblood of what I do as part of continuous delivery. Every single commit and push should be built, tested, and maybe even deployed as part of your CI/CD system, depending on the maturity. This is going to hinge a lot on how much automation you have set up. As part of continuous delivery, the only thing we can really do is prove that software releases won't work. We can't prove anything's good, we can only prove bad. So we take as many pop shots as we can to get it out. If it survives, then it goes to production. Same thing needs to happen for your command line utilities. Myself, I'm especially guilty of this, probably especially in the end, of writing untested code because it's just me and I'm DevOps and I'm cool. That I really had to fight against myself. And I find probably a few of you here have the same issue. Especially happens in stuff like bash scripting when you're writing those utilities because they don't come with the kind of testing and maturity that you get in Python. So when you switch to Python, you don't generally tend to throw that all in. Now you can. Travis CI is great. Works with GitHub. If you're doing public stuff, it's usually the best bet. Docker is built in. All the bells and whistles. Yeah. Yeah. There's options if you're running private GitHub repos and stuff like that. If you're in the enterprise, you typically have your own implementation. You probably got Jira, so you probably got that for free, all that kind of fun stuff. Some of you will have GoCD, all that kind of stuff. You generally, with these utilities, you can build as much logic into the actual utility itself for building. So when it comes to CI, you're just running a simple command. For the Windows folks, I threw this in because it was a guy doing a Windows presentation. There's AppVeyor, which I believe is also free. Is a Windows build and basically Travis for Windows, for those of you doing Windows development. Doc testing. This I'm still struggling a little bit with. It's a little bit tricky when it comes to command line implementations. It more applies to things like when you're writing standardized libraries. The Sphinx system will have sort of wrappers around input and output. So you can see here there's test code. It says print output, test output. There's a little bit of managing of output, and then it expects this text. This allows you to kind of embed actual tests into your documentation to ensure that when you're doing things like examples, that they actually work. A lot of those things that we have in the software development community is that as soon as you write documentation, it's dead. It does fun things like validate the URLs in your documentation are valid. Helps prevent against typos, ensures that people get links to the other documentation that the underlying libraries might use. And it's especially important if you're publishing a SyPy package, mostly because it's the public gateway to the community for other people to use your package, and mostly because SyPy doesn't support Markdown. That sucks. Feedback. So when developing and writing these kind of tools, you want to always ensure that you're going out and getting as much feedback from the community as possible. If you're in the enterprise, that's the guy next to you. That's developers, other DevOps. That can even be people like UX or non-traditional software roles like project manager. You're going to get a lot of good feedback about how your tools are written, a lot of feedback about how your documentation works. Just go out and grab that from other people. GitHub, as part of these systems, you can get sort of a lot of fun automation in terms of badges. These are all kind of like your public pride that says, you know, these are my tests. They pass. My software's good. When someone comes to see and use your library, they're going to see these and know that things are at least okay, or that you're very good in Photoshop. Especially when it comes to community integration, respond and close your GitHub issues. Especially when it comes to command line utilities, because people are going to have a lot of questions around these. There's other parts of the community that can help as well. People like here at SyPy, if you're writing something cool, tell someone about it. Give a talk at SyPy. There's other places like on the PySlackers community that we run. We've got a system called Shameless Plug. If you've got something to plug, and you want to be shameless about it, come and tell us about it. Other places like Reddit, RPython, and Twitter are nice places, but they're very high activity, so it can be a little bit tougher to get this kind of feedbacks. The Python organization themselves maintain a list of community places you can also kind of reach out to, but these I find are the sort of main places that I got feedback. Cool. Sounds like a lot of work to set up for a simple command line utility. Who's going to do that? Not me. It's flawless with asterisk live demo time. Wow, didn't expect the live demo. No one expects the live demo. There is a Python library called Cookie Cutter, which basically takes copies of systems and creates new projects for you. There's one that I especially like that I found recently, and one of the reasons I'm writing this talk called Pi Library. It integrates like 90% of these items all into a simple automated system. You get the standard interaction thing like you would with like create React app that asks you a billion questions. So we can kind of come through these as I pretend to be this other person. Package names and distribution names will all be reflected when your SyPy config if you ever upload it. Versions for your semantic. Choose a license. See extension support. So there's a lot of questions in here. We're looking for a few. Select your test runner, especially like PyTest. This is all right. Doesn't matter to me anymore. Linter, I really like Flake 8. Command line interface. If you choose click, you'll get some nice click stuff out of the box. Command line interface bin name. So if you ever install the pip package, it'll automatically generate that nice entry in the bin. We're going to call this demo. Coveralls. If it's a public project, you can publish your coverage tests. Skip that. Code coverage, yes. Landscape, I don't know what that is. There's been a few options that added. Cookie cutter will automatically pull new versions of this from Git, which are stored in GitHub, which is a few extra options I'm not familiar with yet. Sphinx theme, that's if you ever publish your documentation to something like read the docs, that's the automatic documentation theme that comes up. Sphinx doc test, yes. Travis, so if you're not an internal application and you're an open source project running on GitHub, select Travis, and it will automatically generate a nice Travis config that runs all your talk tests. At Thayer, if you're a Windows developer, you're not. Requires IO, it's a new one. Just let me know for that one.
Requires IO is the tag for the checking your comments.
Oh, cool. So it gives you a nice little system that's automatically generated here. Okay, if you're ever using SyPy, there's a command or a setting in SyPy configuration called cache. Turn it on, it's awesome. Especially good for live demos, because I don't know if I have internet or not. I don't. So talk to the automation that goes through and runs all your unit testing, everything that I've talked to you about before, stuff like your coverage. It'll do nice things like, hey, have you checked in everything that you're currently working on into Git? Which is super handy for those second commits where you're like, here's the actual file. This will go through and test it in everything that I've got locally installed. I've got Python 2.7 and 3, whatever is in brew. Get your nice coverage stats for both. If you add the extra option in the talks configuration, you can have it amalgamate your Python 2.7 and Python 3x coverage stats. Ooh, okay, so that's going to jump out to the internet. Maybe? Or maybe not. Cool. Just the fun of the live demo waiting. Cool. All the URLs are valid. We've got a dump out of everything that's succeeded. If you want to do stuff like dump out your JUnit formatted unit test reports, it can do that. Everything is stored here in the talks.ini. Everything from generating your test environment reports to your cleanup to your checking your environment for your Flake 8 tests, your Sphinx documentation build is all built into here. And then that's it. You've got a nice, fully tested, ready to automate system to shove into your CI. Any questions?
These talks, people actually want Gradle to come up. Quite. It's part of it. It's not entirely a build tool like Gradle is a build tool that takes the time on the configuration and shit like that. Talks is more of a coverage. It's like Travis, yeah.
The question was, is Talks like Gradle? Yes and no. Talks does things in the declaration like Gradle does, but it doesn't do just that. It does that with a bunch of Python environments.
Yeah, you just check multiple things. It doesn't, because Python does not require you to build stuff, right? Like in Java, you need to compile it to like the
Rachel,
How do you get on PyStackers?
pardon?
How do you get on PyStackers?
How do you get on PyStackers? You go to pystackers.com and you slap in an email address and you get an invite, because that's how Slack works. It's kind of weird. Yeah, you gotta. Yeah. So we use a Python library on PyStackers. If you've got any questions about PyStackers, I could probably do a talk about what it's like to run a Python community. How many million Django questions you've got?
so many
Yeah, pystackers.com. Feel free to come join us. We have rooms for Python, Flask, Help, data science for those inclined. If there's anyone here like that.
Two of us. At the very least.
We've got some community projects going as well. We've got a GitHub repo where we try to collaborate with other members of our team. If there's someone who's new to the whole software collaboration issue and you want to come jump in and help with some Python projects, we've got some existing Django site stuff. And we're always open to starting up new projects. Any other questions? Yeah.
Yeah, with not much unit tests in place, will the talks help you to identify the issues when you're trying to migrate from Python 2.7 to 3.x?
So the question was, if you don't have many unit tests in place, will talks help you cover your migration from Python 2.7 to 3.x? It will help because it will run the stuff in those other Python versions, especially once you hit the coverage for multiple Python, like Python 3, 4, 5, and 6. If you hit them all, you'll get a better idea of what specific things are breaking in your Python implementations. But it's no replacement for actual coverage, or sorry, for actual unit test coverage. But if you obey the test and go and read all your tests first, you won't have that problem.
Will it at least show you the syntactical errors? I mean, at least like the errors which are related to the version of Python, like the updated version of the Python, like what you need to implement.
The question was, does it show per Python output of your unit test failures? Yes. When you run that talk, it'll kind of go through each sort of system and run those tests individually. Any other questions?
Long story short, test and keep testing.
Thank you very much.
Yeah, if it is an existing system.